Now, another common and important operation that you'll come across when working with matrices is called scalar multiplication. So that simply means if we take the matrix A and we multiply it by a constant, say the number 3, the resultant matrix is what we call the scalar multiple of matrix A. And again, performing this operation is very straightforward. All we do is multiply each of the elements in matrix A by the constant 3 at the front. So 3 by 2 is equal to negative 6, 3 by 0 is equal to 0, 3 by negative 1 is equal to negative 3, 3 by 3 is equal to 9, 3 by 3 is equal to 9 again, and 3 by 2 is equal to 6. Okay, so this new matrix is a scalar multiple of the matrix A. Now for matrix subtraction, let's say that we want to do the operation matrix A minus matrix B. We can consider this as matrix A plus negative 1 times matrix B. So again, note that negative 1 here is a constant. Okay, so negative 1 times the matrix B equals, so again we multiply the negative 1 into all of the elements of matrix B. So negative 1 times 2 is negative 2. Negative 1 times negative 2 equals positive 2. Negative 1 times 0 is 0. Negative 1 times negative 3 is positive 3. Negative 1 times 1 is equal to negative 1. And again, negative 1 times 0 is equal to 0. Alright, so the resulting matrix, if we add matrix A plus negative matrix B, we get negative 2 plus negative 2 equals negative 4, 0 plus 2 equals 2, negative 1 plus 0 equals negative 1, 3 plus 3 equals 6, 3 plus negative 1 equals 2, and 2 plus 0 equals 2. And note that because we turned the minus into a plus, and we multiplied matrix B by negative 1 to essentially form a new matrix, it doesn't matter which order we perform then the operation. So commutativity is maintained here. So I can just as easily write this as negative B, the negative of the matrix B, plus matrix A, and I should get exactly the same result. Well, now let's see if the distributive laws hold for scalar multiplication. So again with the matrix A, let's multiply this by a scalar multiple R. So R times A, this gives me the matrix negative 2R, 0, negative 1R, or negative R. So 3 times R is 3R, 3 times R again is 3R, and 2 times R is 2R. With the matrix A again, let's multiply this now by a scalar multiple S. So this will result in the matrix, so negative 2 times S is negative 2S, 0 times S is 0, negative 1 times S is negative S, 3 times S is 3S, 3 times S again is 3S, and 2 times S is 2S. Okay, so now if I was to add the matrices RA plus SA, what I get then is negative 2R plus negative 2S is equal to negative 2R minus 2S. 0 plus 0 equals 0. Minus R plus minus S equals minus R minus S. 3R plus 3S equals 3R plus 3S. 3R plus 3S again is equal to 3R plus 3S. And 2R plus 2S is equal to 2R plus 2S. Okay, so these operations are quite tedious, but bear with me. In fact, I'll write this as 0R plus 0S. Okay, so this results in, we can factor out a negative 2, so we can say this is negative 2R plus S, and we can factor out a 0, so we have 0R plus S. We can factor out a negative 1, and have negative 1 outside of r plus s, 3 outside of r plus s. In the third row we have 3 outside of r plus s, and finally in the position of the third row and second column we have 2 outside of r plus s. Okay, so common between all of these elements is the factor r plus s. So let's factor that out. So we have negative 2, 0, negative 1, 3, 3 and 2. And effectively we're multiplying this again, so this is the matrix A, by the factor r plus s, or by the scalar r plus s. So thus we have just demonstrated that scalar multiplication is associative for addition, and as an exercise you can also satisfy that scalar multiplication will be associative for matrix addition as well. So if I add the matrix A and B and times it by the scalar A, I should get the same result as the scalar R times matrix A and the scalar plus the scalar R times matrix B. Okay, finally let's use the matrix SA, and let's multiply this by the scalar multiplier R. So again, every element is multiplied by 2r, so we have minus 2s times r, 0s times r, minus s times r, 3s times r, 3s times r, and 2s times r. Okay, so we know that for each of these elements that multiplication is commutative and associative. So I can rewrite each of these elements as 2, and then I'm going to multiply this as rs grouped together. So following, then we have 0 by rs, negative outside of rs, 3 outside of rs, 3 multiplied by rs again, and 2 times rs. And again I can treat what's common for each of these elements as an outside multiplier. So again we're left with just the matrix A. So the matrix A multiplied by the scalar R times S. So what we have shown here is that associativity also holds true for the multiplication of 2 or more scalars. Okay, so before we finish this video, let's establish some laws for matrix addition and matrix scalar multiplication. So law number 1, matrix addition is commutative. So which means matrix A plus matrix B is equal to matrix B plus matrix A. Law number 2, matrix addition is associative, which means matrix A plus matrix B plus matrix C, I can group any of these together and get the same result. Law number 3, the additive identity is the 0 matrix. So matrix A plus the 0 matrix of exactly the same dimensions as A gives the matrix A. So that's law number 3 part A. Law number 3 part B, the additive inverse of the matrix A is negative 1 times the matrix A. So if I add matrix A and the negative of matrix A, so scalar multiplication of negative 1, this will give me the 0 matrix of exactly the same dimension as matrix A. Law number 4, scalar multiplication is distributive. And for part A, we say that it's true for the addition of scalar multipliers. So as we've shown before, that r plus s times the matrix A is equal to R times the matrix A plus S times the matrix A. And for part B, we say that it's true for the addition of matrices as well. So if we add matrix A and matrix B and multiply this by R, then this is the same as R times A plus R times B. Law number 5. Scalar multiplication is associative, and as we've also discovered before, if we multiply two scalars together and then multiply that by the matrix A, it's the same as saying we multiply the matrix A by S first and then times this by R. And finally, law number 6. Cancellation laws hold for scalar multiplication. So this is a fundamental law of algebra and applies to matrices as well. And what is meant by this is that if we multiply R by the matrix A and R by the matrix B, well, this equality only holds true if and only if matrix A is equal to matrix B. Also, if we say that R times the matrix A is equal to S times the matrix A, well, this equality again only holds true if and only if the scalars R and S are the same. Okay, so we'll wrap this video up. In the next one, we will look at matrix multiplication. If I've been able to help you, please like, subscribe and share. And if you can, I would really appreciate a small donation, as these videos take a lot of effort to produce, and with the proceeds I will be able to help you more. Thank you for watching, and I'll see you next time.